Hello everyone, this is Felipe, and I'm going to explain the most important aspects of my project, the Meta Heroes NFT game. I have taken inspiration from various NFT games like Gods Unchained that use the ERC 721 token standard to permit players to truly own their gaming assets like cards, characters, and much more. I've based the ideas for mechanics and gameplay on Yu-Gi-Oh!, a popular trading card game across the globe. The separations of types in Hero, Magic, Rune, and Environment bear some similarities to that game as well. It was inspired by it, as I have said before. It is meant to be a fun, competitive game encompassing PvP battles for evolving your account and cards and trying to be the best player out there, even with some rewards on the side if you are good enough on the game. And I have envisioned that by using BSC, we can offer a fast, reliable blockchain service that does not cost an absurd amount of cash like using Ethereum. Although BSC is much more centralized, it still uses the EVM. We will focus only on the smart contract implementation side of things. So, in this project and presentation, we'll only focus on the smart contract side of things and variables and functions, that kind of thing. The game itself may be executed as a centralized server on a container service, and its players may access the data and functions in the contracts by using the front end provided in this scenario. However, that is not the case today. We have here the requirements. We must it must be possible to mint 4 types of different NFTs using a static tribute of 0.05 BNB and 10,000 experience points. Those are recorded, stored in the variables that accompany the contract, the Meta Hero token contract that will be shown in the second phase. When minting, the card that's generated must be randomized. We use some rules to randomize the, the, the creation of card, the minting, their attributes. They'll be all randomized using the SHA-3 catch function and announce and some code that some functions that I've got on the web. The system must have a rarity system divided in 5 tiers: 1 star, 2 star, 3 star, 4 star, and 5 star. These define the strength of stats and or effects of the cards. The system must have blueprints. That part we can kind of rule it out. I've done some research on interfaces, on contracts, and I found out that's not how contracts work. So we can rule that one out. 5, minted cards both must be based on an Excel. That's the same thing I just said. Hero cards must have the following stats: attack, defense, health, and energy cost. Magic cards must have 1 or 2 effects. That's a little typo on there. For one set of possible effects that each base magic card must have defined. In fact, we have created the contract. I have created a contract in a way that we can only mint magic cards with 2 effects and not with only 1. Also, there is a little bug associated with minting magic cards that we will see later and I will explain. Rune cards must have an effect that boosts any of the 4 stats for hero cards: attack, defense, HP, health, and energy cost, and can only be equipped to hero cards. The system must have an experience point balance for each player address that's currently playing the game. That will be explained on the second part. The system must have a player level. The system must make it possible so players can evolve their player level with their experience points when they have accumulated sufficient experience points for such. Each level acquired doubles the amount required of experience points for the next one. And finally, the system must have a matchmaking point balance for each player address that is currently playing the game. Okay, now we'll pass to the second part and see the smart contract structuring. First, let's see a little about MetaHeroToken.sol, the contract that mints and keeps track of all NFT cards of all types. So we have 4 types of NFTs that are going to be minted and stored inside this contract. These are the hero card, the magic card, the rune card, and the environment card. The hero card has, as we have just explained from the requirements phase, they have rarity, rune slots, attack, defense, health, energy cost. Rune slots does not it's not an attribute. It's intrinsic quality for the card. So rune cards cannot give us extra rune slots. And rarity is defined in the moment of minting. We will show the functions later. Magic cards, as we have explained in the phase before, it has rarity and 2 effects. This has been refactored to work using arrays, because we cannot have a struct that use this absurd amount of variables, because Solidity can only have 16 variables in the stack at the same time. So there is some little limitations that doesn't allow us to make the contract using this type of approach. Okay. Rune cards have rarity, an attribute. So yeah, the attributes defined as a uint. However, we should have one of these 4 expected values: 1 for attack, 2 for defense, 3 for health, and 4 for energy cost. Okay, it's still recording. So let's continue. Environment card. It has rarity. It has a boolean, however, that was refactored. It now uses a uint that has 0 or 1, 0 if false, and 1 if true. And an attribute, just like the rune card, the environment card makes it gives a buff or a debuff based on the negative effect. 1, in this case, true, will be a debuff. 0 will be a buff. So the attribute that's defined on the attribute variable will give positive value if false, and a negative value if true in the negative effect. And finally, the attribute bonus, that is the literal value of the bonus that is given to cards when the environment card is used. This specifically is environmental card. So we have variables of the state of the contract. There is a nonce for generating cards. They are random functions that we will explain later. Uses this nonce for randomizing the process of creating random numbers. So it uses this nonce. Uint constant min price. This is the variable that will store the value of all transactions that are emitted in the minting process. So all types of cards are minted using always this quantity of money, 0.05 Ether. In this case, 0.05 BNB. There is an array of possible effects that was refactored. We will show it later. There is the 4 card arrays for each one of the NFT types, and there is a mapping for each one as well. So addresses will map directly to their NFT card counterparts. So all users, all owners will have complete ownership of their cards through this data structure. And finally, the data structure that links all NFT cards in regardless of typing by their token IDs and their holders. So you can iterate, no, you can search, you can use a key to access this data structure, and you have the address of the token owner and the functions of this contract. The constructor uses the default ERC721 construction. The function mint is the function that we use to mint all cards. However, it was refactored, and now we have 4 different separated functions in the contract to mint all types of cards separately, because of the same stack limitation that Solidity has that I explained before. Okay, and function get on heroes, so we can get all heroes that are given address owns. Same thing for magic, the same thing for runes, and the same thing for environments. And now the property functions. This functions is a view functions that returns all properties of a type of card. You have to use a function for the type that you are trying to see its properties. So get hero property will return in all values associated with the hero property, with the hero card, like their attack, their token number. You get the idea. The same thing for magic, rune, and environment properties as well. This function run has been refactored. It now uses some different approaches. I understand it completely. I've taken some parts of the function from the internet, but we'll show it later how it is working right now. Okay, there is some functions to get the total hero cards, the total magic cards, rune cards, environment cards that can be important to the owner or for the players to know how much cards there are minted for all types or a specific type. And finally, function withdrawal that it makes it possible for the contract owner to retrieve the tributes from players after they mint their NFT tokens, so the tribute can be used for something else. Now about MetaGeroHame.sol, the contract that runs the game. We have the game struct that has game ID, winner, loser as addresses, and winner XP points, loser XP points, winner MMR points, and loser MMR points that will be stored in the blockchain. This will map each game and values to the game state, and players will be able to trace back all of their stats from these, as they will get stored associated with the players, and they are stored separately as well. We also have a nonce that will be used for the random function. We have the player nickname. All addresses can be mapped to a string, and this string will have the player nickname if the player has set a player nickname for himself. The player experience points will keep track of all player experience point balances from the using the key, the address as key. The same thing for player level, and the same thing for the MMR, matchmaking ranking. And finally, the contract for MetaHero token itself. It is a variable that is inside this contract. The game array is here, and also a mapping that will map all games that a certain specific user has played, and will place them inside of this mapping with the key being his own address. So a player or an employee can make a query here and see the games that has been played by this player. Okay, so here we have the function set and get nickname. That's very self-explainable. add experience, subtract experience, add MMR, subtract MMR. In the case player wins or loses a game, so we can change their balance of points for both experience and MMR. The function level up is a function with certain rules that will be explained later. That is a function to level up the player, so his player level here will be incremented and he will be able to access more features of the game in the centralized server. Here it doesn't have that much of the important aspect. And finally, endgame. This function will run after the game has ended. It will calculate experience point and matchmaking rewards for both players based on their current levels and MMR, and returns both their updated MMR and experience balances. This function get user single games has been renamed to get user games, and it gets an array with all past played games IDs for the given address. And the same random function that we use on the other class is used here as well. So now let's begin the last part of this presentation. We have deployed the contract using Ganache. Ganache is, just a moment. I'm going to separate these in three parts. Okay, so now we will run the tests and see the results. I created some tests so we can see what's happening inside the application, and most importantly, we'll be able to see our NFT cards and their attributes and some inner workings of the game. So let's run the tests. First, let's migrate the contracts. I had to redo this part of the explanation because the last video there was something wrong with the Google Meet when I was recording and I lost the recording. So I am redoing it now. Okay, all migrations done. Now let's test the application. I'm using Ganache with Truffle so we can test and use our code here and inject it using Truffle into our simulated blockchain on Ganache. So let's link our Truffle project with our application that will be sent to deployed on Ganache test chain. Oh, so let's save and restart. While Truffle is loading the tests. I don't know if it's possible to read because letters are small, characters are a little small. Okay. Okay, I might have to try this again. Okay, we have solved that last problem. Now let's begin with the tests. So the tests begin. We'll let them run, and later, when they are all being executed, I will explain each one in detail, so it will be easier to understand. These tests that involve minting of new NFT tokens of all four types, they take some time to complete because they have to fire up some transactions and they have to execute some more complex code to generate the NFT cards. There it is, the hero card test with some uh, placeholder hero cards that are being created by the tests and printed out so we can see their attributes. There's all hero cards from the first account, sorry, the second account in the accounts array. That accounts array is this accounts array, these 10 accounts that come with ganache when we create our test chain. There is a bug on test 11 because for some reason the minting of magic type NFT tokens is not executing properly. It's reverting the transaction. Maybe something with the fact that the struct effect uses uint array inside him. I don't really know. Solidity has many limitations, some of which I am not, I do not have knowledge of currently. Rune cards have been minted and printed out here, so we can see them. And now we are printing out, minting the environment cards and transferring them for the fifth account. And now we are printing them. And there are tests 17 has some bug associated with Solidity that cannot find my function, add experience, and add MMR. And I don't know what's happening, so I skipped that test. All right, as I have explained, test 11 will fail because the transaction is going to revert for some reason. I don't really know why. So now I will copy everything and I will explain in more detail in another text visualizer, so it will be easier to illustrate and explain everything. Okay, here we are. Now let's augment this font size and I will explain the tests. First, the first test makes the first account of the array the owner of MetaHero token. The second test makes the same thing, but for the head MetaHero game contract. That is the contract that controls all aspects of the game and has the MetaHero token as his as a variable, as an attribute. There is test 3, get contract name. There it is, name of the contract, MetaHero token. There is test 4, get the NFT token symbol, that is meta. There is test 5, get contract owner. It returns the first address of our accounts array, that is this one, is the owner. So he's the one that's being returned by the function after it has been set in the first function here, in the first test. So test 6, it will create some NFT cards and will allocate them, transfer them to the second account on the accounts array. That is this one. And here are the cards. A hero card has his token number, his rarity, here is 4, rune slots 4, that is the max amount of rune slots, attack, that is a random number between 2 and 5 times rarity times 5. That is attack, the same for defense and health. And energy cost, it's a little different because the number, random number will vary from 1 to 3 times rarity times 5. So there are our placeholder cards. They have been sent to the second account. So test 7 has printed them all out. Test 8 will get the token owner for token ID 10. That's the first hero card we have minted. And here it is. This is the second address on the accounts array of Ganache. So it has been executed successfully. Here it is, test 9, get all owned tokens from a address. So we get all hero tokens that have been minted on the last step. And there are their token numbers. And here we are, the test 11 that fails because for some reason it reverts the transaction when minting magic cards. Test 12 tries to get magic card token URI, but it also doesn't work properly. So test 13 will create 10 rune type cards and we'll transfer these NFT cards to the fourth account of our accounts array. And there it is, it's that one. So as per the rules, rune NFT token IDs will always begin with 3. So all rune cards have a rarity and attribute. 1 is attack, 2 is defense, 3 is health, and 4 is energy cost. And an attribute bonus, that is the actual value of the bonus that gets added to the hero card that gets this rune card equipped on itself. So here are our rune cards. Finally, we create our environment type NFT cards and we transfer them to the 5th account on the accounts array. That is this one. So here are our environment cards. They always begin with 4. Environment cards have 4 attributes: rarity and flag that says if it's a card that gives a positive effect or a negative effect. Debuff means it's a negative effect if it says yes, a no if not. So if it says no, it will be a positive effect. Attribute here is 2, so defense gets a buff. It's get a attribute bonus, and the value for that attribute bonus is 2 in this case. So a very weak card. Here it's a card that has no, so this card will give a positive effect. It will add this number on all cards on the table. This one will subtract this amount from the attribute, the affected attribute. That's it. This test we have skipped it because it has some unsolved bugs. And test 17 will try to simulate the aftermath of a game that transpired on the centralized server. So it should return to us the addresses of the loser and winner respectively and their MMR balances. But for some reason, that's another one that's failing, and I could not solve this problem I executed this specific test on Remix IDE and I got some limited degree of success. It returned the actual values, but it had some problems. So this one has been skipped over. It tries to show loser and winner here, but they are from the test code for the JavaScript code, not the contract. And the last test, this should transfer token contract ownership from first account to second account. So first we have the first account as owner of the contract, that is the first address on this list, and then we transfer it to this one, and finally we use a function that gets on the it use the function on the contract to get the owner, and the function returns the value of the second address of this list. So it executed successfully. That's it for the tests. I will briefly show the contracts code here, so you will be able to see the code. If you have any doubts, any questions, there it is. I think this is the problem that's happening with the magic cards, because I'm using this uint 14 variable here, array. Here are our arrays and structs and everything. The min price for minting cards and everything that was detailed on the requirements document. Here are our functions. Some of them have been refactored, others are new, because I didn't know at that time that I would need these functions. So there they are. As I have explained on the previous part, minting cards, the function that mints cards, I have separated it in 4 separated functions, because that works better with Solidity, because of the memory stack of limitation that only allows 16 variables per stack. A stack of 16 variables. Okay, that's it for the MetaHero token contract. And now MetaHero game. There it is. Struct game, all mappings, player nickname, player experience points, player level, matchmaking, ranking, games that gets all of the games are recorded here, and all users have a array of played games. Games they have played all get stored here in this array. So there are our functions for this contract. And that's it. I hope it was a fun ride. Thank you and goodbye.